Yo, yo, what's up? Let me see if my stream's on. Why does it look like this? Yo, yo, what's up? Wait, it works, but why does it look like that? Am I tripping or what? Oh, there we go. Okay. Seems to work okay. Cool, cool, cool. Okay, so today we're going to be doing some LeetCode and other programming stuff. I really want to do graph problems and um, other stuff in preparation for like a competitive programming thing I have tomorrow. So I guess I'll do some leak code, maybe do some caddis. Um, maybe I'll go through the previous contest that I did. Yeah, I think that's a decent idea. By the way, I'm like terrible at a lot of this, so I need to like look through. Um, I'm gonna have to like look online a lot, but first let me find the contest. How do I see the problems I did? Um, no. What about this? Nick Woo. Do I have to do like? Okay, there we go. Um, wait, no. Why does this not show my? Why does this not show the the teams that I was in? There we go. So this is practice 7, practice 6, and oh, confused. Right, I think this was us. Yeah, so practice, this is 7. What about practice 6 though? Well, yeah, this is not the right one. Let me go back for a second. Oh, why does this not show the other practice I did? I'm gonna have to look at that real quick. Um, is I using a different account? Okay, yeah. So this was the other competition. I don't think I'm allowed to like try this, but oh no, I think I can. I think I can. So yeah, yeah, I can try it. So this was practice 7 as well. This is what? Wait, what? I'm so confused. Gotta treat someone. What about the one we did recently? Yeah, this is still me. Okay, so this is the next one. Right, okay. So I'll go through some of these problems, although I'm not the best at these things, but I need to prepare a little bit for the competition tomorrow. Um, then I can use these as examples to figure out what kind of things I need to know. So let's start off with this one. Cancel. Okay, so this one, I'm just gonna ignore this because this was just like a brute force. This is not what we need. Let's look at this one, which we solved. Uh, okay, so this one was also pretty easy. This was just basic math. This was not really anything complicated. So I'm gonna ignore that as well. I'm gonna try doing stuff which is like a little bit more something that I don't understand at all. Okay. Right, right. So these types of questions, and it just which game variants that kid should get. I'm gonna also try and see if I could do stuff in C++ just in case, even though I definitely think it's way easier to do everything in Python. I'm just gonna try C++ just because why not? Just in case we need to do something like faster. Although it shouldn't necessarily be required. Okay. The kids at school are obsessed with a new video game of collectible Pokemon cards called Pokemon. Their goal is to catch them all by completing this. Typically, they do this by playing the game, encountering Pokemon, catching them with a Pokeball. Pokemon games are released in different variants. Each variant contains a number of Pokemon, which some of which are exclusive to that variant. For example, only Pokemon Blue allows encounters with the unknown. Okay. But share with a friend who has a Meowth Pokedex. This man may either own Pokemon Blue. Task is to distribute Pokemon variants to the kids so that through trading among friends, each kid can get at least one. So I think this is some sort of a graph form, by the way. Let me just play some music for this. So I'll go here. Let's play this. Because why not? Um, one alpha, and it's just one for each kid representing which variant the kid should get. Let me. I want to make sure it's not too loud. Hold on. Okay, this is probably good. Okay, so one line, three integers, NMK, the number of kids with N is this, number of friendships, and number of variants. So there's two variants. There's 8 kids with 5 friendships. So the first kid is friends with, so one, two, three, four, 5. So these are the friendships listed. 1 is friends with 2, 2 is friends with 5, 3 is friends with 4, 5 is friends with 6, 7 is friends with 8. So these both can trade. These both can trade. These both can trade. These two both can trade. I mean, I do think this is some sort of graph form, but like, I need to get detailed onto that, so I'm going to start from the basics. Let's see. What is this? So we have BFS, DFS, number of cycles, detect cycle, flood fill algorithm, cycle, union find, Kruskal's minimum spanning tree, logical start. I would guess. So I would guess, I mean, let's just start off with the basics. Traverse the graph using the breadth first search and find the order in which the nodes are visited. Breadth first search is graph traversal algorithm that starts from the source node and explores the graph level by level. First, it visits all nodes directly adjacent to the source, then moves on to visit the adjacent nodes of those nodes, and then proceeds. Okay. 1, 2, 0, 2, 1, 0, 1, 3, 4. What is this? Something else. Let's play this shit. Okay, so how does this even work? I don't get it. 1, 2. Wait, I put. Oh. 2, 3. Wait, what? 2, 2, 3. 2. Oh, there's an adjacency list. I see. Ah. I think it's a matrix. Is it not? Right. It's like this. Or is the list or a matrix? I can't type, dude. What is this? Adjacency list or adjacency matrix? Okay, that makes sense. So the output is we start at 0, we go to 1, print 0, print 1, print 2, first neighbor of 2 that hasn't been visited. Okay, I get it, but how do you do it? So it's an undirected graph. Okay, this is C++. Let's do this stuff in C++ first. Let's also close this. Let's say, okay, graph.cpp. Okay, let's just include some random stuff first. Turn 0 here. So it's saying BFS for single connected component. So you give it this vector, and then okay, let's do that. Let's also like kind of do this. let's do it like this. So we're doing vector int BFS, a vector of an int, and we're giving the address of that, and that's our adjacency list. And why are we doing the address? Wait, what? Oh no, it's a reference. Sorry, why am I saying address? But like, I didn't include. Okay, I mean, let's just do it. Dot size, that makes sense. Vector bool visited. Okay. Vector. So we have a array of boolean and so this is the index, I'm assuming. So right now we haven't visited this. Okay. Okay, so that's the result. We have a queue. Wait, what is source? Int source equals 0. Okay. Okay. Q.push source. Fine. While Q is not empty, int cur equals Q.front. Q.pop. Res dot push back. Cur. Let's try understanding what this does first. So we have this v for the size of the array. Okay. We have a visited thing, and we're saying for that size it's 0. So if I understand correctly, in this example, the size of this would be 1, 2, 3, 4, 5, 6, and somehow visited 0, 1, 2, 3, 4, 5. Okay, we're saying 6 is not visited. Fine. So we're saying this 4 has never been visited. I guess that's fair. Okay, fine. And then we're saying we have this is the result vector. We have a Q. Q is like first come, first serve? FIFO, right? Yeah, Q is FIFO. Okay, first come, first serve, fine. Then we're saying this visited thing, source is equal to true, so it's visited the first node. Then we Q.push that source. And while this Q is not empty, int cur is Q.front. Pop it and put it back. Okay, so then let me see if I can do this myself. I kind of get the idea. So after we push this back, don't we want to like do we want to Q.push something here. And that's gonna be like, so we start at 0, right? So this. Okay, the sound fucking sucks. My bad. Okay, so let's see. I want to push this something here, and that's gonna be like, so right now we're at 0. It's kind of interesting because I thought push source, or we pushed 0 here. q.front. So current is now 0. Result.pushback 0. That seems wrong, I think. Wait, what? Wait, I need to look at this. 4x in the adjacency current. Okay, this makes sense, but why did you push back current to res? That's just a number. Right, so yeah, this part makes sense. This is what I was about to do, but I'm just confused on why we pushed back. So if not visited x, then this is going to be here, and then over here we can say visited x, sorry, equals true. Now this works out, and then over here we're just going to push that x. Fine. But why did we push her to result? That this makes no sense. Okay, I mean, let's just try it, I guess. Nothing wrong with trying. Wait, what? I can type something? Wow. Let's just copy. Um. Okay. By the way, I think this has to be. I don't know actually. Is this right? I don't know if this is allowed. I think it needs to be like this. And then all of this needs to be like. I think. This is so annoying. Okay, so we have this. I guess we can pass this into BFS. Yeah. And we get some sort of vector. What do we get? We get vector in. Res equals this for I inside res stood C out I guess. So what do we have? So let's just do g++ graph.cpp vector does not name a type. In function BFS was not declared in the scope. Oh. Wait, what? Do I have to like stood? Oh god. Okay. I have to do stood everywhere. Stood here as well. Plus graph.cpp. Cool. We get 0, 2, 3, 1. That does not seem right. I thought this is supposed to be 0. Wait, it is 0, 2, 3, 1. But it doesn't do 4, 5. Oh. I guess it'll do it if it's fully connected. So like that. Zero, 2, 0, 1, 3, 4, 2, 2. Let's try that again. Graph 0, 1, 2, 3, 4. How does that work? Is this like, so we're just assuming that there's a 0. Like that's why we set this as 0. There just has to be 0, I guess. And we're saying we're gonna start at 0. We're just gonna push forward. Okay, I guess that sort of makes sense. But I mean, so we started this. So why did we go 0? Oh, so we do 0, 2, 3, and then we go 1. Okay. That makes sense, I guess. Sort of. Of a disconnected unidirected graph. Let me get more comfortable. Yeah, let's see how to do this for... The problem with this is it starts at 0. It's a 0, it's a 2, and then pushes source. Well, it's not empty. Int current equals q dot front, which is 0. Q dot pop. There's dot push back current. For int x in adjacency matrix current. I think, do we have to go from each? Doesn't current just go from, if we haven't visited x, we can push it in. Yeah, but instead of doing this like push stuff while q is not empty, we just like this is all fine. Yeah, that's what I thought. We literally just go through all of them. But wait, what is this BFS connected? What's this? Oh, what? Oh, I see. I see. I guess we do that right here. Kind of. No, we can't. Guess that kind of makes sense. Let's see if I can do some problems. I don't think I'm good enough to do these caddis problems yet. I guess I could try. I'm assuming we have to build some sort of graph. Inevitably. Maybe? Maybe not. Let me see if I can like draw it out real quick. Whiteboard. I'm gonna draw with my mouse. It's gonna be terrible, but still. We have one. Oh. We have 1. It's connected to 2. Which is connected to 5. Then we have like 3. Which is connected to 4. And we have 5, which is connected to 6. And then 7 that's connected to 8. So this is like one of those disconnected graphs. 1, 2, 5, 6, 3, 4, 7, 8. So the truth is, if any of these disconnected graphs have like individual entities, well, individual lines. Okay, so if the number of nodes in any of these disconnected graphs is greater than this number, it's straight up just impossible. So we have 3 here. I mean, we can do that, but anyways, so it's straight up impossible. However, and if it's not, then it's possible. And the way you would do it is, you start off here. Let's just say this doesn't exist, which is 1, 2, 5, right? It doesn't really matter. If as long as this person and this person has 1 and 2, if this person has 1, they can trade with 2. It doesn't really matter. We just need does it. This is really loud. Let's see. The kids' school is obsessed with a new video game of collectible. So, I mean, realistically, right, in this example, if this person has 1 and this person has 2, this person can have 1 and this person can also have 1. It should still work. Okay. So I guess now we need to do this whole disconnected graph business, which is right, here. Wait, no. I guess we can do DFS of graph. Is that like any better? Yeah. Recursively visits all vertices that are not visited yet. What's the input here? So somehow we need to construct this. I mean, I guess we can put it into some sort of adjacency matrix. One, 2, 2, 5. Yeah, okay, that kind of makes sense. But this is not gonna be good because like it goes to the extreme point first. We have to do it through BFS, I think. Essentially, you have to write this code. Is it easier in Python? Not really. For a single connected component. Okay, so it's the same code for a single connected component. It's what we did here. But we need the source. And we need a vector pool of visited. Wait, what? Yeah, visited. Can I type? Thank you. Vector int of res. I think. Stood. Okay. I guess sort of. So then we could just have. You just get rid of all this. Okay. We have the adjacency list. We have a source which we start from, which is given to us. We have a visited. I thought the visited, why do we need a visited? If it's disconnected, why do we need a visit if it's disconnected? I'm confused. This visited part, visit all unvisited neighbors of current node. Sure, but like, can't you just make your own visited thing? Because like, I thought, um, if it's disconnected, then that means that you haven't visited anything there. I guess it's because you don't know the size of the vector you're dealing with, kinda. No, you do know the size. Whatever. I'm just gonna take their word for it. I mean, over here we have visited defaults. Okay. Let's just see the code of what they write below. They have another function called BFS. Uh, okay. And then we have res here. Okay. And then we return res. Fine. Okay, so let me see. So int v is equal to adjacency matrix outside source. Get rid of this. So who visited these falls? So we're going through every single value, and if it's not visited, we do BFS connected. That makes sense, but like, I see. We're completely doing the visited stuff inside this. That's why it's an and. Address of. Or sorry, it's not address of. It's the reference. I keep saying address of. Say ampersand, but okay. That makes sense, I guess. Technically, let's see if I could just do this problem. Like if I did so first the way this would work is I would do std in what is it? NMK, and then I would do something like for how many of these connections? Oh, so for or while m minus minus, I would get numbers in, and each one of these things is like, what is it? play this song. So I'm gonna play something else. Play this. So in this case, the adjacency matrix, let's do 1, 2, 3, 4, 5, 6. And, wait, is that how this works? Yeah, it is how it works. So for each node, we have like this. So let's just say it's like till 5, right? Just to make it, or like let's just say it's till 4 to make it simple. 1, 2, 3, 4. So in this scenario, 1 and 2. So we draw a 1 here. 2 and 5. Let's just ignore that. 3 and 4. Draw some 1s here. 5 and 6, whatever. We draw 1s there and terminate it. Is that it? And then everything else is a 0? Obviously, these are always going to be 0. And because this is a unidirectional, it's not like, sorry, not unidirectional. It's bidirectional, it doesn't matter. It's like, yeah, it goes both ways. If you do 1 here, you have to do 1 here. Okay. Wait, so how do you construct this? (2D matrix). Initialize all of them to 0. I guess that's pretty easy, I guess. But like, this one takes an adjacency list though. Frick. Can you convert between them? Can you convert from age matrix to age list? And I type things. Iterate through each row of the matrix. For each row, iterate through its column. One is found at J to the adjacency list. I don't think I should do it like that. I think I should, from the beginning, have this as an adjacency list, but I don't know how to do that. Let's look at an example over here. Alright, let's not do that. Let's go here. So this is like an adjacency list, right? So we're starting at, so we have 1, bang. Also, I don't understand how does this work? Oh, it always starts at 0. I see. But does this also always start at 0? I don't think so. It does start at 1, 2, 3, 5. It does seem to do that. It does go in ascending order. Very suspicious. Probably trying to tell us how it wants to be an adjacency list. Create an array of 9 empty indices. Uh, what? What did I provide? Add the connector or connections. Okay, I kind of guess I have an idea. This? Segmentation fault. What? Oh, I guess I don't have it defined this stuff. I guess we can do like that. Bro. Still segmentation fault. assuming this stuff works fine. So that stuff works fine, obviously. So I'm saying, I'm pretty sure this is how you do one with sides, right? Instruction for creates a vector and elements. Let me get rid of this stuff first. Still, so that's not the problem. Yeah, but this should be fine. Uh, there we go. So that kind of works. So that gives us the input. Now we have this BFS go, right? So we need to somehow track the sub thingies. Hmm. So I guess that's like a call to this BFS connected. Right now, I don't even think we need this to return res. I think we can make it return an integer. That would be smart. I think. Where's the disconnected graph? So this is disconnected. Yeah, we don't even return anything here. How about we go up here and say instead of returning this res thingy, you what the hell? You return int while q is empty. I'm just gonna do like int I equals 0 and say I mean every time we push something, right? It's I plus plus I. And then return I, probably. And then we say int num equals this. Let's make this like whole thing. And say if num is greater than, and we pass in k. Yeah, we pass in k. And then we say if num is greater than k, should see out impossible. Then we say we break. No, we get just return. We return -1. I guess we don't return. We just can we just return? No. Whatever. For now, we just do break. So that should be for the impossible case, not for the possible case. Uh, I think we can just submit like in this scenario, we just say we do the bare minimum and everything else we just fill it with ones. uh, okay. So we say if num is greater than k, this, else. Sorry, what the hell? Yeah, else. By the way, what? Okay. Else, what we do is we say while num. No, so this is so while num minus minus. Wait, so for let's just do this. For int I equals 1, I is less than or equal to k. Yeah, and then plus plus I stood see out I, and then for the same thing, for I equals k, well, I is less than or equal to num minus k, we just print out uh we just print out k. Maybe. I don't know. This is a little sus. Okay, let's just try it. I mean, what's the issue? It says it's impossible. Wait, where did I get the extra 1, 2 from? Oh, it started putting 1, 2, and then it says it's impossible? Okay, let's just FG this. Go down here. We don't need this anymore. We just want the business to have it itself. What is the issue? If num is greater than k. Is this every time we push, or? Oh, it's because we're only doing things we've visited? Question mark? No. Well, let's just do a test. Let's just say if I do it over here, what happens? So, It does 1, 2, and then it says it's impossible. First off, let's fix a really quick issue. This is definitely this. Okay, so now we need to do this. Num greater than equal to k. Let me just check on the stream real quick. Let me just check on the stream real quick. Okay, cool. Should I just play some like lo-fi or something? Like, is there anything like good lo-fi? What's this? That's cool, I guess. This stuff is pretty good as well. Maybe I should listen to this. Yeah, this is tough. Maybe I should listen to this. Yeah, it's like the best one. Who's this? Paul Lewis. Who's this guy? Who's Paul Lewis? Oh. Okay, let's figure out the issue here. Also, I don't know what this is. Bro, I swear there are other songs that are like fire. Whatever, man. Play like. Okay. BFS connected. Q. Okay, let's print this nums out. Sounds like Star Wars. Zero and then six. Okay, that's clearly wrong. What the heck? I guess this is fundamentally wrong. I see. I see. I see the issue. This is actually way too loud. Stop. Stop. Maybe I should do this in the pre-pass? Just go like 4 int I. Sorry. Uh. If dot size is greater, sorry, is less than, okay. State cout impossible return give it 1 actually return 0. Okay, so we can do this, and then we can say in this scenario it's never going to be impossible, and say we don't need this like k business. Okay, where did I call it? Okay, then we can go here, we can say we don't need this. And we can say seems possible. What is this? What's wrong with this? Huh? What? Return res, yeah. I mean, I'm just gonna have to figure out like this. Oh. I see. I guess we do need K. Okay, I guess we do need K. My bad. Int K. We just passing K here. That's that. There we go. No return statement and function returning non-void. Ah. forgot to change this to void. Oh my god. I guess we do need it. What? Okay, wait. Do we? Why am I even traversing through this? Is it to find each thing? But it's already in this format. Why can't I just do one for loop and get it done with? Like right here, why can't I just say else? And just do this over here. Instead of this, I'm gonna get rid of this. We could just do add I dot size. What now? Well, theoretically, we'll have it then. Let's say nothing. Okay. Impossible. Okay. Oh. Maybe? Please? Still impossible? Man, what? Add. Maybe. Maybe because I need to do like. No. It is NMK, right? Yeah. It's okay, and it's impossible. I think there's something wrong with this. Obviously. Did see out. The heck? Oh, oh, wait, what? Oh my god, dude. So we have 1, 2, 2, 5, 3, 4. Oh yeah, yeah, I see this one. We have 1 connected to 2. 2 is connected to 1 and 5. 3 is connected to 4. 5 is connected to 3. No. No. 1 is connected to 2, 2 is connected to 1 and 5, 3 is connected to 4. Sorry, 4 is connected to 3. 5 is connected to 2 and 6. And 6 is connected to 5, 7 is connected to 8, 8 is connected to 7. Okay, so this works. Ah, I see. We need to add 1, including yourself type thing. So let's just get rid of all this. Plus 1. Okay. Okay, okay, okay. But why is there so many 1, 2, 1, 2? 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. I mean, we're getting somewhere, but then I don't know why there's so many 1, 2s and stuff. Oh, it's because we're doing things we've already visited. That's why we need the graph. Oh my god. All right, I'm gonna skip. I'm gonna take a break from this and do something else. So let's do like OpenGL. Um. Okay. So right now in OpenGL, I'm just trying to like get like a window and whatnot. I've already done this a while back in Java, and it was really annoying because I hate Java. So I mean, look, we can try doing this in C++ now. Yeah, these problems are just a little too hard. I need to do it on leetcode. Like I need to do some leetcode problem. What is this? Anyways, let's look at it. Got medieval lo-fi. Genshin lo-fi. This one was fire. This one was kind of cool, but I don't know what happened to this guy. He was like, he's pretty lit. I don't know what happened to him, but I mean, he's still, I guess. That's funny. Okay, let's go. Let's actually read through this stuff a little bit more. Okay, so we do have. I did do the basics. I did all this. The window object holds all the windowing data and is required by what is this? Create this window. If window is equal to null, fail to create window, return -1. Make the current context. Stop. The previous is okay. The size of the rendering window so OpenGL knows how you want to display the data in coordinates with respect to the window. Uses the geo viewport. Location of the okay. Transform the 3D coordinates are processed. Process points to would be mapped to 100 and 450. Callback function. Framework success call without. Okay. I wonder how this window. Cool. So we have all that. Cool. Yeah, so this all makes sense. Right, your engines. render loop. So we set this while command over here, process input. What song is this? Is this from Attack on Titan? Swap the color buffer. Right. We need to swap buffers and pull events. Okay. I think we did that. Terminate, sure. So we did this input. So we did this process input over here. Window if escape true. Okay. And a process input every second. So we put that over here. Cool. So we're doing this GL pull card, okay? Okay, so this all makes sense all now. In OpenGL, everything's a 3D space, but the screen or window is a 2D array of pixels, so a large part of OpenGL's work is about transforming 3D coordinates into 2D pixels. As by graphics pipeline of OpenGL, the graphics pipeline can be divided into two parts. So first one, your 3D coordinates to 2D coordinates. Second part transforms your 2D coordinates into actual colored pixels. We'll briefly discuss the graphics pipeline and how we can use it to our advantage with advanced pixels. The graphics pipeline takes as input a set of 3D coordinates and transforms these to pixels to screen. The graphics pipeline can be divided into several steps where each step requires the output of the previous step as input. All these steps are highly specialized. They can be used executed in parallel because of the parallel nature of graphics. Okay. The processing cores run small programs on the GPU for each step of the pipeline. This small program is called shaders. I see. So I think OpenGL really just communicates with the GPU and makes it so that like packages all your data into like vertices into its own object. Like we can make our own struct with all the vertices and data and stuff, but like the problem with that is it's gonna go through the CPU and we're gonna have to manually tell the CPU to kind of process all that data. OpenGL basically wraps it into their own internal object, which runs on the GPU automatically. So I guess that's the whole point of this, and we use GLSL open to basically tell the GPU exactly how to do that, like how to transform whatever vertices we gave into some actual like what operations we want the GPU to do on them, I guess. Let's get rid of this. Manipulate list of three 3D coordinates that should form a triangle in an array called the vertex data. This vertex is a collection of vertices. A vertex is a collection of data per 3D coordinate. Okay. This vertex is represented by attributes. Those things are called primitives and are given to OpenGL all the time. Okay. It takes as input a single vertex. The main purpose of the vertex shader is to transform 3D coordinates into different 3D coordinates. More on that later. The vertex shader allows us to do some basic processing. Okay. The output of the primitive stage is fast of the geometry shade. The geometry will generate other shapes by emitting new vertices. Press to the rasterization stage where it maps the resulting primitives into the corresponding pixel on the front screen. Before the fragment shaders run, clipping is performed. Clipping discards all fragments that are outside your view. Okay. There are no default vertex fragment shaders on the GPU. Start learning modern which is okay. To start drawing something, we have to give OpenGL some input vertex. Is a 3D graphics libraries, all coordinates are in 3D. Transformer 3D, all the 3D coordinates. Okay. Okay, what is this NDC? Once your vertex coordinates have been processed in the vertex shader, they should be normalized device coordinates, which is a small space between the. I see. Vertex buffer object. Okay. Okay. Generate buffers, bind buffers. Okay. Copies the previously defined vertex data. So, I mean, we did this. This makes sense. Makes sense. Buffer data, size of vertices. Oh, I see. So full vertices over here. I see. Static draw, and it's automatically gonna go to the VBM. Cool, cool. Unsigned into vertex. Okay, so we did that, I think. Unsigned into vertex shader, vertex shader source. Cool, cool. Okay. Okay, so I think we just copy this and somehow like put it into the fragment shader source. So we have out void main. Back 4. F, 0.5F. Okay. Now we have the fragment shader. This. We did this. Compile the shader. Cool. The shader brings the final link version of the multiple shaders. To use the recent compilers to link them to a shader program. The activate shader program. Okay. Okay, we did that. Attach shader. Okay. Okay. GL link. Okay. Use program. Okay, we don't need that anymore. Okay. The vertex shader allows us to specify any input we want in the form of vertex attributes and vertex. Okay. I thought the compiler would like not. Oh, I guess because they're using their object, they probably. Matter of fact, I think we can take a look at that real quick if I'm allowed to. I think I can go to gen buffers VBO array buffer right here. I think it's this. Can I go to it? Oh, I think it's GD. It's GD. GD. Yay. GL array. Huh? Oh, what? Are you serious? Is this just definitions, bro? It's just definitions. You cannot be serious. And it keeps going forever as well. We're only 50% of the way there. Okay, screw you, Mr. Definitions. Um, I want to see. I'm assuming they have something like pack like that. I think. Where's the pact? Oh, Pragma pack. Do they have that? I think I didn't see that. Maybe they have it. Who knows? Ah, yeah. This is what I was talking about. Attribute pack. 64 bytes, alignment. I see. Okay. Anyways. Opposition interrupt the verdict data. Okay, so this is 0, 3, 4. First specifies which vertex attribute you want to configure. Size of the vertex attribute. Okay. Okay, let's get back to it. Right. 1 or 0. Let's try. What is this call? I see. Draw the object. thought we already did the GLU's programming. Okay. Think we do it after? What is this? Oh, VBA. I thought we already did that. Oh. Wait, what? Yeah, right here we did unsigned it. We did Jill bind buffer, BBO. We did the static draw business. So I guess over here he's saying we should also do Jill bind vertex. And we do this random VAO. Where did that even come from? But okay. Into VAO. Unsigned into VAO. GLGen vertex arrays. Okay. Now what? I did the enable stuff, right? Yeah, I did. Okay, cool. Now what? GL use program should work. I mean, who knows? Huh. Oh, I see. Stop. Cool. That seemed to work. That did not draw anything, unfortunately. Maybe it's because I see. Maybe it's because we need the triangle to be drawn inside the maybe this has to be in here? I don't know. There we go. I was right. Let's go! So beautiful. I don't need to change that. Okay. I see. 0, 1, 3, 1. Wait, what? 0, 1, 3, 1, 2, 3. I don't get it. Let's try it out. Um, it's like if we want to draw a rectangle, it'd be like this, right? You need 1, 2, 3, 4. 1, 2, 3. Wait, 1, 2, 3, 4 points. You need 4 points to represent. I think what they're saying is that 4 points. Which this thing has 4 points, right? But if you draw it in the primitive way, first triangle, second triangle, you need 6 points. You draw this, 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 then you draw this again. You go here, then you go here. So what they're saying is instead of drawing this like that, you just have 4 points. You draw these 4 points and then say, okay, start at 0, draw this, then draw this, then draw this, go back and draw this again. Draw this and then draw this. But it's still 6 columns. If that makes sense. I guess it. I guess we're drawing it. We're just not storing it. I don't get it. Hmm. I see. 118 minutes. Wow. Okay, let's get back. Let's make an EBO, I guess. So let's like kind of do this like this, I guess. I don't need this much space, so let's go up over here. Cool. Let's do this. So now they're saying we need an EBO as well. So we have VAO, VBO, EBO. Cool. Very nice. Unsigned int, EBO. I don't understand what this unsigned int business is. Why are these buffers in unsigned integers? Like, I would expect it to be a pointer or something. Let's just ask Gemini. It's just an ID, huh? Ah, that makes so much sense. It's in the GPU's memory. Wow. Cool. Wow. Okay, so we have an EBO. We do the same bind buffer business. So we can do element EBO. And then we decide the indices this time. And we say indices. We say static draw. Cool. Elements. Wow. Okay. That's like pretty convenient, I'm not gonna lie. So all we have to go down here. Where's our GLBind buffer? Huh? Ah, right here. We say GL draw elements. 6. Cool. Wub mode, similar to GL draw arrays. The second argument is the counter number of elements we'd like to draw, which is 6. Okay. So we have to like change this every time. Like I'm assuming that's obvious. It's gonna be done like automatically. Type of indices, which is the type of okay. Offset, which is 0. Okay. A VAO stores the GLBind buffer call. Wait. A VAO stores the GLBind buffer calls, and the target is to. Sure, you don't unbind them. Okay. Sure. Okay. I mean, we can try it. Oh, oh my god, not this stuff again, bro. Wait. Oh, oh. What did I do? Where's mine? What? Okay. Okay. What the heck happened to this? Why is this an error now? What? Frame buffer. Huh? What? Okay, let's just sorry. Main.cpp. Oh, I guess I can do it. Whatever. Expected. Oh. I'm stupid. The messages are so cryptic, bro. It's crazy. There we go. Huh? Huh? What the hell happened? Oh, it's because I. They literally said over here, do not. Don't unbind the element array buffer before unbinding the VAO. And I think I did exactly that. Maybe. But wait, I didn't even unbind stuff though. Did I? Wait. GL bind vertex array. Right here. Bind buffer VBO. Buffer data. Buffer data. GL bind buffer VBO. Ah, I see. Gotta do it like this. GL vertex attributes. Now it should work. Dot ended. There we go. I see. Can I resize this? I just realized why this is so bad. Or not performant. It's because my WSL2, which is where I'm running this, does not have does not have GPU support. I don't think WSL has GPU pass through. That is WSL. So I think it's actually running it on the CPU, technically speaking, or the not the CPU, the integrated graphics. Yeah, GPU. Really, that's pretty cool. Let's. Okay. We can do wireframe mode if we want to, but I kind of don't care about that right now. Alright, let's go next. So now we have this GLSL C-like language where we use shaders. I see. What is this? Vertex attribute. The output returns are no 16. Okay. This is. Ah. Okay, wait, what is it? For layers to create a new vector, as long as there's a vector's component is not allowed to access Z component of the vector. Okay. Vertex data. I see. Wait, to define how the vertexes are organized, we specify the input variable to the location metadata so we can configure the vertex attributes on the CPU. Layout equals 0, the vertex shader. That requires an extra layout specification for its inputs. Dude, this, I mean, I tried the other day to get this to work on Windows. It's super, super, super annoying. It's like not even funny how hard, or not hard. It's just like you need to like download things like the old fashioned. You can't just like copy commands to do stuff. It's really, really annoying, to say the least. So we get input vec3 position, and we give out a vertex color. We give a vector 3 to vector 4's constructor. GL position equals vec 4. We just add we just add 1.0, which is like what, the alpha? What's Wait, no. X, Y, Z. What's what's this? What is this 1.0? We give vec3 the vec force constructor. Yeah, but what is this GL position? This GL position is not being used because you're only outputting this vector color, sorry, vertex color, which is just some dark red, and that's not even doing anything. Since uniforms are global variables, we can define them in any shader stage we'd like any any shader stage we like, so no need to go through the vertex shader. We're gonna get something to the fragment shader. We're not using this uniform in the vertex shader, so there's no need to define it there. If you declare a uniform that isn't used in the GLSL code, the compiler will suddenly remove this variable from the compiled version, which is the cause for several frustrating errors. Uh, there's a GLF2 get time. Okay. We do some sinusoidal time value. Okay, we're just changing it up. Actually, like, this time value doesn't even matter. We can start at like 1 and just because time is just going to increase, right? But it doesn't really matter, or I guess it does, kind of. I mean, our while loop should automatically just, add 1 every time we go through the loop or something, right? I think, no? I mean, think about that. I mean, that's going to be done based on FPS and not standard time, which basically means if you have higher FPS, the colors are going to change faster. If you have lower FPS, they're going to change slower. I guess, yeah, you want to be time independent, or you want to be FPS independent. Okay. Another thing I need to like figure out is what I'm actually gonna use this for, because I'm gonna get pretty burned out super quickly. If there's actually no use for this, I'm just studying it for fun. Because I have no intentions of making a video game or anything like that. I also don't have any intentions for making an engine for the sake of making an engine. I'm not really super passionate about video games, like making a video game. I mean, so maybe there's some other use cases. What's that, Gemini? Scientific visualization. Don't care. Computational fluid dynamics. I'm not, I mean, I like physics, but I'm not that much of a physics guy, to be honest. Professional CAD software. Not interested. General purpose computing on graphics processing units. This I'm interested in. This also I'm interested in more infrastructure side, not actually coding learning models. Like maybe I'm interested in like the math, like doing something from scratch, like doing some back pro. There's a really good website called deepml.com, I think. This I really need to get back into. They have some really cool things associated with them. Let's continue. Like for example, like one of the harder ones is like let's find like super hard ones right here. Like a package says kernel SVM implementation, GPT text generation. Uh, yeah, like you can basically do it from scratch in Python, and this is like this is so cool to me, because I mean just look at it. It's so cool. Like it's not like you're just importing some PyTorch model and you're just doing it. It's just like you're doing it from scratch. Whoa, 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 whoa. I don't know. Anyways, this is a website I need to get back into. I need to do more leetcode. Maybe I'll do some leetcode prompts and end our stream today. How long have I been streaming? It's been a minute, so I mean, like, yeah, I'm just gonna do some leetcode prompts and the stream. I'm getting a little tired of this OpenGL business. So let's close OpenGL for now. Let's close. I mean, let's just keep that open just in case. We can full screen this. And let's do some leetcode problems. I do want to do some graph related problems just for the sake of it, because I need to learn graphs. Let's see, sorting, greedy. I guess, wait, I can just use leetcode. Let's just go to the roadmap. Let's sign in. I mean, I've been like really, really struggling to keep up with this. I mean, I have done a decent amount, but it's not enough. Let's just go to do graphs. All right, let's just start with backtracking. Let's not do it like that. Did I try this? Okay, let me get rid of this. Or actually, don't do it like that. Can I just restart? Yep, confirm. Okay, so the way backtracking works is I don't remember actually. Okay, so the way I kind of remember is I do like def backtracking, and then I pass in something here. I'm gonna. By the way, I'm gonna start using Python for this because it's just really, really. What is this? Pause. What? Stopwatch and stopwatch. Stop. Okay. The reason why C++ is just too annoying for this, and I want to learn Python, so I'm just gonna use Python for this. I'm just gonna learn Python along the way as well. Okay. So backtracking, this is like a very simple technically, but I have no idea how to code it. The idea is that you start off and you just choose this or not choose this kind of thing. And the way you want to go about it is, so first you want to define some backtracking stuff, and then you do backtracking. And you start at 0, like that. Maybe just return that. No, you don't. No, I don't know. The way it works is, I actually don't know how it works. So you start off. Okay, let's. I think you do result equals arrays. What am I doing? Array. I think you can just do dot append inside an array. I don't know. 2D array in Python. Can you just make a 1D array and then append inside if I want to? Defining 2D array Python. Oh my god, dude. And there's 2D with nothing. What is this, dude? Whatever, man. I think you just do it like this. So this is the result. And I say, how does backtracking work? We start at some value. I have no idea. I'm gonna search it up. How does backtracking work? Intro to backtracking. Choose, explore, check validity, repeat. Okay, okay. Show me the general backtracking algorithm. Stop, 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 stop. What is this, dude? Stop. Just. Do I really have to look at code for this? No. Labuladong. Yep, yep. This is, bro. Freaking, I need to like save this website. I remember this website. This website's awesome. Okay. So this is the general idea of backtracking. So you have the path, you have choices if condition, if end condition is met, result add and then 0. For choices in choices, make choice, backtrack path, choices, undo choice. I see. I see. So what we're gonna do here is I think this is gonna be, if I remember correctly, this is gonna be like res. Uh maybe this is like index? Then it's like res? I don't know. If res, sorry. What is our base case? What is our end condition? I have no idea. Choice. Maybe you need like a queue or something? No, you don't. Do you? No, you don't. Maybe you do. I don't know. Maybe Mr. Leetcode can teach me. I'm trying to think of the base case. We start at this. Maybe we say if res dot size, but I don't think we use res. I think we actually use something else. Sorry. We say if nums dot size something and then return or I plus 1. have no idea. So okay. Let's go through this first. We start at one. We can either choose one or not choose one, right? So how do you how do you do that? I think you just res dot append. Maybe you have two backtracking things like this, and then for both of them, it's like you choose or not choose. I have no idea actually. The heck is this? English. What is this? Oh, I see. Idea. Wait, what? How's the? He just showed me the idea. Wait, this is the solution. This is the idea. Whoa, whoa. I don't remember it being this hard. The heck is this self-taught track? No, stop. I don't need this visualization. Um, Wait, what? It was not this hard. Oh, okay. Res. I I swear it was not that hard. I think you just do nums here. You go here and say if. Sorry. guess you do num here and you say num dot append. No. Let's just close this. I swear I had submissions for this. Let's see. Did I not? Editorial. I don't remember. Hmm. Binary start like nums backtrack nums plus 1. No, this is not. I swear this is not right. Let me just look at the solutions over here. Because I swear on everything, there was like a very easy solution. Let's just go Java. Why is there no C++? Python 3, sorry. If I equals the length of num. Oh. Wait, no. This is a right sort of pen subset. This makes so much sense. Okay, so basically what we're saying is we have we're starting with nothing, and this is a solution, right? By the way, we return result here. We're starting with nothing, and we're saying so this is the start and this is the path, okay? And you do results, you directly get result. First off, I think this needs to be here. Result dot append the current path. For I in range, and we go from start to length of nums, we can backtrack. Wait, backtrack. Zero plus one, so we need one. The length of nums is like. Let's go to length of nums is 3. We go from start to 3. But each time we do a backtrack, and over here we're saying I plus 1. We do path. Oh, sorry. We do path plus nums num. Whoa, this is kind of hard to understand. Backtrack, I plus one, path plus one, I don't get it. Let's read it. Use recursive at each step to decide whether to include the current element in the subset or not. Recur for the remaining element. So this is the I'm assuming this is the I don't get it. Choosing to add, is this choosing to add? I mean, kind of. Ah, okay. After returning from the recursive call with start equals 2, remove the last element. Where are we removing? Okay. Yeah, I don't really get this. I'm not gonna submit this right now because I don't really understand this. I'll try it later tomorrow once again after I get some more practice. I'm gonna stop streaming now. Maybe I'll try some problems later after I eat. Thanks for watching.